actually, that I was a little bit concerned about the having other people need SolidWorks.
Other people need
SolidWorks. You are. I got a mute here. Okay.
Sweet. That's what happens when you start streaming and you actually don't think you're actually going to be successful with it. So, welcome people as you come in. I am Tim. That is David. Say hi, David.
Hi.
And we are going to do some Wintergatan CAD stuff. Ongoing with this stream, we have been working on, the ultimate purpose of what we're doing is to get design the marble machine in SolidWorks, the touring version of the marble machine. Martin has said multiple times and actually reiterated on our team meeting this week that he's pretty sure that the machine that he has built in his house in France is not going to be the machine that is going on tour. So we are going to be doing designing the manufacturable version of the MMX that will eventually get made to be resilient enough, disassemblable enough, if at all, and to go on the world tour. So that's what we're doing here. And preparation for that project, we're doing two different things. One is that we're working on kind of the reference geometry of the marble machine. And we are also doing a test project, which is the paper-fed music box, which we are designing as kind of a test project. And so I have David here with me. David's another longtime Wintergatan E-team member. Machined some of the only parts on the machine that haven't gotten angle grinded still.
Feel a little cheated.
Yeah, maybe because they were built the right way the first time. So yeah, that's it. We're doing that, and let's just kind of dive into it. I don't have comments. Oh, I do have comments up. I have Tom Nelson and Dan Carroll. Hi guys, thanks for stopping in. So let's get into it on the music box side. So keep on learning things not to do in SolidWorks. So if you see here, I have a collaborative space in 3D Experience that's called AmSite. This is a client of mine. It's actually a company I'm joining as a co-founder. And I made all of these bookmarks and I made them in the wrong 3D Experience project. So yeah, they're supposed to be in the music box project. So next week we're going to have Sean O'Neill, who works for SolidWorks, and to kind of walk us through a workflow for getting things set up. But from what I understand, the way that they want you to work with all these things is they want you to use all of these use bookmarks. And if you see here, we have a bunch of bookmarks, and it looks, bookmarks project, bookmarks, marble machine touring. Andre made a test bookmark back in the day. Can I delete it? No, I probably can't. Watch this. You are unable. So anyway, I don't know why it is. Like I've made all these bookmarks, but when I look at them, when I try to delete, failed. When I try to get into them, they're not in. Anyway, fun stuff.
Yeah, I haven't actually touched on the bookmarks yet. That's not something I've even bothered with.
But apparently this is the only way we're going to be able to organize the project, right? So if MMX has, how many parts? 2,000 unique parts? Something like that. Because everything else in this platform is totally flat. If we look at I get out of this and look at, these are my files for the various iterations of the music box that I've had, and it's unnavigable. It's really
not only is it flat, it's also like doubled. There's two of everything.
Yeah, and you can't turn that off as far as I know, right?
Because one's a physical product, the other is a CAD family, and I have never really received a satisfactory explanation why that's the case.
Yeah.
I'm sure there must be one somewhere, but
from what I understand is that this, even though this is the logical way to do it, this is not supposed to be the way you're supposed to do it. You're supposed to be going into your bookmark editor for whatever reason, and looking for stuff that way, right? And look at this. I have an AmpSite bookmark. Like, why would it be in here? I just don't get it. So that's fun stuff. I don't know why it's having such a hard time with that. The platform is just anyway. I'm hoping so. We're gonna have Sean O'Neill on next week, and we will. He's the guy who we worked with at SolidWorks, along with their local value-added reseller, which is Hawk Ridge. He's the guy in SolidWorks who's kind of championing this stuff. And so I chatted with him on Wednesday, and hopefully he'll be able to explain like how you use this and like what a good workflow is, how you get these things set up. Because right now it's confusing. And if I wanted to find apparently you can. Oh, by the way, look, this is Music Box Project. And these are chassis module based. These are MMX bookmarks. So, yeah, like, can we move those to a different, area? Or, yeah.
What's underneath the little caret on the left side of those bookmarks? Do they expand?
Yeah, they do. So if you actually had files, they would come up in these bookmarks.
Ah, okay.
Yeah. So that would be how you kind of, and you can nest the bookmarks. And so I think the bookmarks are your file folders, right? They can't call them folders because that would be too easy. So yeah, like if we were going to say, it frustrates me because I already have everything wrong here, right? It's like it's already wrong, and how you pull up the like switch from this is Music Box Project, how you switch from that to another project. I think you just have to like here's MMX Touring, right? Now I guess I have to relaunch the bookmarks editor. And Andre's file is still there. So these aren't just the bookmarks that are in the MMX thing. Anyway, so obviously I don't understand what's happening, which is amazing for interesting YouTube content. Sorry, guys. But anyway, that's the let's see. Do we have Music Box? Oh, there we go. So maybe I did do it right, and maybe I didn't think I was doing it right. So here's Music Box. I made that bookmark, and then I have the box frame, control electronics, Music Box hardware.
Max Brown just put out a message on YouTube. He wants to know if you want to
properly sent out. Yes. I don't know. You're gonna have to tell me what properly sent out is supposed to be, Max.
I guess he's trying to say you didn't do it properly.
Yeah, no, that's understood. Yeah, I even posted my link in like the in the right place on Discord, I think. But anyway, so yeah, so here we go. So I don't know why this guy is locked, but assembly 1 is reserved. Open with
Probably me. That's most likely me. In fact, I think.
Owner is David Lewis. Yeah.
Mm-hmm. So yeah, weird. I don't have that open right now. It must have. So that file actually crashed, and it must have crashed when I had it reserved, and then it just doesn't unreserve it.
Okay. I did the most irresponsible thing, which is that SolidWorks wanted me to update just before the stream. And so it said, "Do you want to update?" I said no, and it says, "Okay, we're updating you." I'm like, "Oh, thanks." I think I said no.
The hotfix thing.
Yeah, the hotfix. So there we go. We got the SolidWorks starting screen over there, which is apparently all right. Where are we now? Too many SolidWorks windows. Okay, that's good.
It's hard for me to deal with the delay because it just gets longer as the stream goes on. Because all I'm looking at is your YouTube, you know.
I wonder. No, because I'm sharing your screen. We'll have to figure that out in a. Thank you, Max. Here we go. Come on, find me. Apparently, you can find. We find SolidWorks content. We open up stuff from here.
What are you looking at?
Oh no, there we go. I don't know why it's so slow.
Yeah, sometimes that takes a while.
Just when you're. Now you got to watch out. Up here it says I'm in the MMXT, but I'm not. I need to be in Music Box Leader. Otherwise, it will save to the wrong place. Sorry. So this is a different skeleton than what we did with all the blocks. And you'll see I have I'm in the layout tab. But basically what I did is I identified in this plane, let's see, where are we? Layout. Or did I do it with blocks? I did do it with blocks. Never mind. I actually followed David's advice, which is don't get used to it, David.
Yeah.
So we have really basic coordinates that show, where that block is located, so we can change, the these different insertion points. And I just made it, you had said that this is too much information, for a layout sketch. But since the pitch of the paper uptake,
you're back on Discord, but
oh, okay.
Okay, here you go. You're back on YouTube now.
Sorry about that. I'd gone the last 2 streams without having any lapses like that. It's interesting.
Yeah, I'd recommend moving your logo box or making it smaller or something. It covers up most of the feature tree.
My logo is freaking sweet, dude.
Right, you don't have to.
You don't want to see the feature tree. I'll just put it right there behind the thing. Are you happy now? Oh, 1 second. Left screen +2. There we go. Anyway, so yeah, this is. Let's see. Do we have bookmarks in here? I don't know how we do this, but I named all the different block things, and this might not be the right one.
So this is actually another argument against using the top level layout sketch as I had showed you guys earlier, because honestly, these blocks are out in the open, right? They're not assigned to anything except for the layout sketch,
right?
And I think you can put them in a folder, but I don't know. I tend to think that as we were talking about before, I'm leaning towards using like outboard layout sketches, like not integrated into the top level. But
okay.
Anyway, all I'm getting at is those blocks being sort of free like that is kind of another argument against that.
Right. So how would you do it instead? Let's try doing it that way.
Yeah. Wow, you went super blurry. Wow. Like super low res.
Really?
Like 100 pixels super low.
Yeah, you were that way at the beginning for this, and the delay is amazing. I'm watching it now. It's like, yeah. So how would you do that layout? Just in a separate part?
No, still at the top level. Just if you look at like when you're in the sketch level, which you're at now because you don't have any parts yet,
right?
You'll see that you can sketch
in the assembly, but not saving a part like a single part file. Just do a sketch here in the assembly.
Do a sketch right there, exactly. And then pick your plane, and you can do it 2D or 3D. I think for the most part. I mean, that's really a matter of like what works best for your design. If you're going to include any kind of gearing or traction constraints or relations, then I would recommend 2D.
Okay. Is this by default a 3D line? Let's see what kind of references I have.
Well, if you just said sketch, then you didn't pick 3D sketch on purpose, so it's just 2D by default.
Yeah. All right. So, all right. So we're laying this out now. You were talking though about a. Let's see. That's our basic, right? That's our basic layout.
Yeah.
So this guy is going to be 180, I think, millimeters. Am I in millimeters? I am. Good. These are 30. All right. So, and let's put some points. No, let's just do this. So if I exit this, okay, I have a sketch here. Do I do this? Make reference sketch.
So that just makes it uneditable.
Huh.
So no one can accidentally like do anything to it. Huh. I can't see anything but a blur though, so I have really no idea.
Yeah. So if it says now I can open it up and say make edit sketch, so I can basically unlock it. But as we start to, okay, I'm going to say make reference sketch. So now I'm going to insert a new part. Oh, I need to save this first, of course. What iteration are we on for this? Oh, here's another thing we need to ask Sean O'Neill about, right? I'm starting a new document. I know up here in the right-hand corner, it says Music Box Project. And so I know it's going to be in the right collaborative space, but like assigning a bookmark to it, it doesn't show that there's a way to do that.
Hey, can I ask you a favor? I don't know if this is going to work or not, but is there any way you could share your screen in Discord instead of having me watch YouTube?
Yeah, I can do that.
Because like it's super blurry. Like I can't see anything in it. There's this weird delay.
Yeah. All right.
I can stop streaming. Oh,
no,
actually,
it's okay. I just don't have to watch you. That's fine.
Got it.
Yeah. So it should be like that. And I mean, I am watching you.
Yeah.
Oops, that's not right. I messed something up. There we go. All right, now you can see me live.
Yep.
Well, we're doing it live. Good. All right. So don't save my resources, bastard. I clicked away from Discord and it was like, your stream is still running. We've paused David Lewis. Like, that's not what I want to do, Discord. All right, so
I can certainly pause if you want. I don't know if you.
No. No.
Okay.
So of course, wait a minute. What I'm showing now is Discord showing you watching my stream. There we go. A little bit better. And now I have to move my little thing again. There we go. All right. So now it's getting like, video inception here. New. We're going to do it through this new part. And this is going to be, what are we going to make? Rollers. No, paper puller.
So,
no, because that's going to be an assembly.
Yeah, I would say you can add an assembly too. I think that might be probably a good idea.
Well, let's put it as a subassembly. It will be paper puller. Did it work?
Boom.
It did.
There you go.
Right, so now we can edit this guy and insert a part into that.
So if I were you, I would actually stop while you're ahead. Don't do that. Turn off edit component.
Okay. Turn off.
Undo it.
Okay. Yeah, that.
Okay. Now look at the grad cap, and you see that little line next to it?
Mm-hmm.
That means that your assembly is not constrained in any way. In other words, this subassembly can just float in space.
Right.
So you want to right-click that, and oh wow,
that's a resolution issue here.
That's all you get?
Well, no, it's because I have an HD screen, right? And because I'm live streaming on, I have this small. Well, it's not a small monitor; it's a 27-inch monitor, but it's a 1080p monitor. It's an older one, and I'm streaming at 1080p. So I want the resolution of that screen to be at the same resolution I'm streaming at. And so, for some reason, I don't get all of the options when I pull up those menus. Isn't that weird?
Okay, so you have two choices at this point. You can either fix it, and there are consequences to fixing it, though.
Okay.
So fixing it means that you're just placing it, and it will never move, and there's no reason that you'll ever want it to move. And it makes constraining things or mating them later on super difficult. But an alternative to that, and actually this is how I think components on the MMX really should be built, is by, instead of fixing it, to mate the, what do you call it? The origin planes, right? Okay. To each other. So if you do that, it'll constrain it fully. And actually the whole point of the, of this particular, exercise, I guess is the right word, is probably you're going to build these rollers. Do you want them to have the same origin as the thing, or do you want them to have their own origin, right? And if you want them to have their own origin, that's kind of the whole point of building a skeleton. Yeah. So that you can put the origin there.
I think I want the origin of everything to reference back to where the machine's going to be, because from a manufacturing context, like the cam, you're going to set your origin for cam stuff based on the solid model. All right, now see what I've done there? So I have 0.1 origin and 0.1, and there's an option for align axes, right? That's what I want to do, right? It sets the two origins together, and we're totally fixed, right? Yeah, you see how that thing is gone? Yep.
So there you go. So now you've got your first subassembly is now constrained with mates to your main assembly.
Got it.
So wherever you want the origin, you decided you want them to share the origin. That's fine. But now it is.
I like that just because it's cleaner. There's no F, there's no dash, there's all that kind of stuff. And Hans, thank you for telling me I'm not streaming at 1080. I thought I was.
No, you were streaming at like 100 freaking pixels, man. That's pretty bad.
You too. Oh, I'm supposed to be streaming at 1080p. And I have a fiber optic internet connection here, which I pay a lot of money for. So, yeah. Anyway, I might have to hardwire myself into the router. All right, so we have the paper puller subassembly here. Now we're going to and we're aligned at the origin. I like that.
Yes.
So I'm going to edit that assembly. I'm going to insert a new part, and I'm going to call this drive roller. And hopefully that shows up. And maybe it doesn't.
Weird.
Or maybe it's just taking its time.
It's hard to tell. No, looks like it's taking its time.
It's still spinning, yeah. There we go.
Here you go. Okay. Now, just realize that every time you create something in an assembly, you're going to be presented with that question, where
Right.
you want your origin to be.
Right. But notice, though, that it is, let's open this guy up. Edit that part. Its origin is the same. Right. So would I do the same sort of thing? Mate this guy with respect to the origin of the parent assembly?
I would recommend doing that, but you have to float it first. Because you see it's got the F. That means it's fixed.
Yeah. I can't right-click on it. All right. It's a little less interesting, though, so let's just start. I want to actually make the part. Why can't I see all of my stuff? Oh, it's this part right here.
Right. Yeah, so you can't actually change the fixed thing until after it's... unless you've closed it. Right. You can't fix or float components that are open.
Right. All right. So now I'm just going to convert entities. This is the drive roller. That's the one. And I'm not going into, we've done the parametric stuff many, many times. I will go back and do that so that we have parameters. But I just want to get a part here because I want to see what it takes to add the bookmarks so that this is all in the right place, right? Because if we are doing this for the MMX, then the we just need to keep the files organized. So extruded boss base, we're going to do that one, and it's going to be a mid plane. It's going to be 72 millimeters, and that is it. I'm going to exclude this. I'm going to pretend it's a hollow cylinder. All right, we have a drive roller. Boom. All right, now we exit that. Let's see if we can, I guess I'm assuming that the workflow now, maybe we can do it through this. I'm going to have to turn David off for a second so that we can see the thing. I'm wondering if I can put a bookmark on this thing right here. By the way, before we do that, I noticed we have some comments here. Brandon's saying that Origin isn't going to hurt manufacturing unless you're having someone else do assembly. Yes, I'm with you on that. It's important that you have multiple people work on things, bring in new SolidWorks files someone else works on, and place them at a certain distance from the origin. Yeah, I'm hoping that we're going to, Brandon, that we're going to be, in this project. I mean, so SolidWorks has given us 20 licenses, so we're going to have 20 people working on this when we do the MMX T, and so hopefully we just have like one way that we do everything, and that's gospel, and you just don't stray from that. And Brandon's saying doing a part replace is easier. Do you know what that means? What he's talking about, David, there?
I'm actually going to your stream right now so I could read the comments. Let me see. Okay. Oh wow.
So Brandon's saying doing a part replace is easier. I think what he's saying is like if it doesn't have its own origin, centric to the part, but centric to the assembly. And it's probably true if you are making another part outside of the context of this thing, or if you have a part that's coming in that is made on the outside and it has its own origin. But I think you're just doing an assembly like normal.
I think that the MMX in the end is going to be a mix of parts that share the origin with the main assembly and parts that have their own origin for a lot of reasons, but including what we just said, parts made somewhere else and brought in are going to have their own origin anyway. But additionally to that, there's a lot of moving parts, and there's so much. It makes a lot more sense for a shaft to be modeled around the Z or Z axis. and revolved around it. And it makes little to no sense to just pick a random one, especially when you're talking about things like the xylophone. I call it almost the xylophone, the vibraphone.
Yeah.
Because it's not on any of the origin planes.
Right. It's
and
on its own thing. Yeah.
Yeah. So my personal opinion is that fixed things attached to the chassis, it's probably acceptable for them to all have the same origin on a case-by-case basis. I think that the base should definitely be like itself on the, we call it the origin planes. And I think that the frames should be, because it doesn't make the frames don't make any sense to have their own context. They fit together.
Sure.
They're static. They don't move. They're not brought in from somewhere else. They're built in place. So it makes sense for that. But I think if it rotates, it should be a revolve around the Z, or if not, then in the XY, etc.
Yeah. So, but if we have, I guess what you're saying is if we have a combination of things where the origin is all the same versus some of them have their own origin, it's not the end of the world.
But it's also it's like there would be reasons that you picked each one.
Yeah.
For like, it's not a random thing. It's
yeah, I'm with you.
Yeah.
Okay, cool. So let's go on. So I was just saving this, and I did save with options, and I clicked it over here, and look, I get this thing that says save with bookmarks. So now I clicked on that, and you see how there's a bookmark in here. This is now frozen. I wonder if it's loading. Oh, select a bookmark.
I think we're getting somewhere.
Yeah, I think we're getting someplace. It'll be great. So I'll have Sean O'Neill on next week. I'm like, I think I just figured this out. So now I'm saving multiple things. So how do I select a bookmark? So this is Music Box, and let's see, Drive Roller and MB4. I have to cancel this. So I think here there's these check marks, like which one are you going to save? And I'm going to save the Drive Roller, right? I'm going to give it a bookmark. The fact that this is that slow is, I guess it's waiting for SolidWorks' servers to go find my bookmarks. But if you have a bunch of different parts and you want to save them into different bookmarks, it looks like it's going to be kind of a slow process. I guess normally you're working in one subassembly, right? So you could apply the same bookmark to all of them. But here we have a Music Box thing and pulling mechanism. Oh, look. Oh, never mind. Look. Oh, sorry. I have to move myself. There's apply to selected and apply to all. Apply to selected. Boom.
Look at that.
Look at that. All right, let's see what else I can add. If this delay, every time I hit the bookmarks thing, is going to be this long, it's going to drive me insane. Let's see if there's any more bookmarks. So that was bookmark Music Box. I thought I had it into Drive, or maybe that thing is truncated there, because I put it under pulling mechanism. Try that again. That's interesting. All right, we're going to save that, and we're going to see how it shows up inside the bookmarks thing on the on the platform. In the platform. God. Hey guys, how's this live streaming experience? Watching my status bar. Do you like it? I think this is fun.
Something's happening.
Something's happening. Yeah. How do you CAD in a live stream and keep it interesting. Yeah,
I've honestly anything I've ever been involved in, especially on this, I don't really consider successful yet. I'm not really good at thinking and talking and CAD, modeling at the same time.
Yep.
It's I've not been able to grasp that yet.
Well, so now here I have pulling mechanism, and I go into here, and looks like I actually already put all of these things here. Maturity state, modification date, pull it over. There it is. Open with, yeah. I thought they have like a 3D preview kind of thing that you can do. Anyway, okay, so we have to clean up our links, but I think what we've learned so far is that your bookmarks do not care about what 3D space you're in, because high-level bookmarks, like all of these, are supposed to be sub-bookmarks of the MMX project. You need to have a music box and an MMX thing, and then there are sub-bookmarks of that. So you hear, like, see, I put all of these things into that. The box frame, box top. Now what sucks here, right? So I've restarted this project so many times.
Me too.
Because we've started it, and then, okay, we want to take a different... So all of the parts are here, and there's no differentiating them. So, we're going to have some kind of rigor, some sort of intellect, some sort of process about how we, if we iterate on a part, how do we clean up the old stuff, or do we?
Yeah, you're running into the exact same questions I am, because, one of my main arguments against the PBS, this is kind of a version of that,
right?
But one of my main arguments against the PBS is that it sort of sets into stone bad ideas that you wish you had abandoned, but you had given like a project number to, and it's already got a part number. And so now what do you do? Like if you delete that entire thing and start over, well, now there's this abandoned thing you have. Now you got to deal with all the data you left behind, right?
Yeah.
And that's one of the main issues. That's one of the main reasons to not want to try something new, right? Because now you're like, oh man, I went through all the trouble of categorizing this, bookmarking this, getting it all set, and now I changed my mind. So now what?
Yeah.
Like first of all, did I just waste my time doing all that cataloging? But second, like now that I have, how do I just get rid of it?
Yeah. And the platform makes it hard for you to delete stuff. I mean,
it's not easy.
Yeah. So a couple of comments. D-Man Vid says, I have access to SolidWorks through school. Do you think through experience will work okay? I mean, so when we did our surveys for the CAD team, like last summer, we have the most number of people who have experience with any CAD platform. Everyone has SolidWorks experience. But when you also looked at what platforms you have access to at the moment, SolidWorks was below Fusion 360. So, we've been doing SolidWorks Fusion 360. The platform, our deal with SolidWorks is kind of like, because we're this international team by definition, and we're spread out, and we don't, we're not a corporate entity that can have its own file server for, files. Like, we are like the poster child kind of project for this, and they're excited about that for this. So, but anyway, to answer your question, if you do have 3D experience, I think even if you have, actually, no, David knows this, right? David has the desktop version, but he can connect into our 3D experience, right? There's a connector. So if no matter how we get SolidWorks for people in this project in its later phases, we'll be able to connect you into this project. And then Brandon's asking, does it save revisions? It has a revision field there. And I'm noticing that. I didn't see that until you asked that. And yeah, it does look like it has A1, B1.
It's got revisions and forks, actually. You could do a lot of pretty interesting stuff. It's something I haven't personally explored yet, because honestly, I'm not settling on I haven't until you finish a design. And say, okay, this is revision 1. Now let me see what I can change, and then save that as revision 2. We're still sort of in the design phase, right? at the absolute top level of the assembly. So making components and then giving them each revisions is a future thing for sure, but it's just not something we've made it to yet.
Yeah. Well, the other thing that might clean this up, though, potentially, is the PBS number thing, right? Which is that if we can't just call it box or left plate, right? Something ambiguous like that. If we have to name it something numerical, it might be that's going to force us into an area where things are clear, maybe.
Yeah, could be. I'm flexible on this, but I can tell you, I am definitely of the team where I think that renaming should come sort of once you've fully baked it, right? Mm-hmm. But like, for example, I think when you're creating a design, you're doing extrudes and valves, and there's bodies, and then there's components and everything. My personal opinion is you just leave it alone. Whatever SolidWorks calls it, you let it just stay that. And then, like, at the very end, when your design is fully baked, you're ready to manufacture it, and you do manufacture it, like, start applying, like Martin's PBS system to it, because now you've sort of, you've taken what you already know is successful, and you are giving it a name. It's like when a baby's born. It's like you're not really naming it yet. You have a list of names, but you haven't really given it one yet. And then you get the birth certificate, and boom, there's baby Johnny right there, and then you can call him Johnny.
Yeah.
I know I know that there's other schools of thought, and I get it. But right now we're in like essentially prototyping. We're in like pre-prototyping phase. We're just like talking about some future thing.
Right.
So that's just
I know. My older son, we had his name like as soon as we knew we were pregnant. Like it's like as soon as we knew the gender, we named him. Younger kid took his time. The other thing that's going to be interesting, and this is something I want to talk with Sean, is that there is I can't find it now because none of these names actually make sense. I was thinking it was under document management. But there is a naming convention, a file naming convention management thing in the platform someplace.
Yeah, I have to assume that's probably the case. And that's another reason why I tend to leave things alone and let the system, name stuff how it does. And then, again, when it comes time to go through with it, like, you have to assume a platform like this is going to have a function that does that.
Right.
Which I hope it does.
Yeah.
That'd be cool.
I'm now in the place where I don't know what the heck I'm doing, and we're live, so. But okay, we were able to come to a better skeleton approach, right? Oh, actually, or were we?
We just kind of just started, man.
Yeah. Well, no, I know, but I mean, we're here at the point where we have an assembly, we have layout sketches in the assembly, we have sub-assemblies and things, and we figured out how we're going to anchor it. Right? It's a little bit better. It's a marginal improvement over where we were with this thing last time we looked at it. So I do want to move on to talking about the MMX and the frame and the stuff that you've been doing, David. So I want to wrap this up. So what I'm going to do is I'm going to try to make a bunch more parts, basically redesign this. Kind of get it up to the level where we had it a few weeks ago. But the idea here is that we will have a paper pulling module, a paper feeding wheel, and then we are going to have a box that has all the electronics in it. But the key thing here is that we're going to have two different modules that go into it. One will be a paper puncher, and one will be a note player. So you could put a paper roll into it, give it a MIDI file, and it would actually create the music, and then swap the head out, put the paper back into it, and play it. I have a meeting request in with Martin to talk about the Phase 2 SolidWorks prep, and also that. If we can do that, I think that might be something that we can manufacture and like do like a licensed Wintergatan music box, actually like build them and sell them or do a small run of them. that we might sell many or several dozens of music boxes.
We'll corner the market.
Yeah, corner the market on applying really high technology to a really outmoded way of making music. But you know what? That's what the Marble Machine thing is for, right? I mean, the engineering way to do the Marble Machine X is to plug in a MIDI keyboard and just play your music. Anyway, so that's we're there. Let's leave the music box. Are we good?
I'm good.
Yeah. All right. So let's go to David. Show us what you have done with the. All right. So to set this up, so David told me that he. I'll give it even. I'm going to step even further back, actually. So David was one of the original E-Team members with me back. When did that start, David? 2 years ago?
I made the parts for Martin in the fall of 2018.
Okay. Oh, gosh.
So I actually mailed them, or FedEx or whatever it was, on, what was it, on New Year's Day 2019.
Yeah, okay, so 2.5 years ago. That makes sense to me, too, because we moved 2 years ago, and when I was mailing him the first parts that I made, we were still at our old house. Anyway, so we've been involved with this for a long time. David has been one of the people who is more focused on getting things right that I know of. Is that a way of saying you're a cantankerous bastard?
Something like that.
Yeah, wants to get things right. And so when we started the CAD team last summer, I asked David to come on and be kind of a sort of a quality control feature, right? So like try to keep the project constrained so that like it was just not the Wild West, right? And so have some discipline about what our CAD standards are, but then also understand how the whole model goes together, where our different connection points are. And any of you who have done a lot of CADing with multiple parts know how easy it is to break a model when you edit something that something else is pulling a reference from. I've been through that more than I care to admit. So we started working on that last summer, and then we had Eric and Andre take over for David when he dropped out and needed to go back to school again. But he wanted to come back for the phase 2 skeleton, which is what we have asked him to do. And so the intent of the skeleton thing for the MMX is that we can have something where we are we can make new files, we can revise the design, we can do anything we want to it with this huge machine, but never break the model. That's the goal.
Right.
Right.
Which is a big ask.
It's a big ask, right? Yeah. I mean, so revising things in CAD without breaking it is hard. And so the idea is to come up with this skeleton architecture, which is kind of what I was showing with the music box, and we're practicing that. And David has been going into the old files, the old MMX CAD project, and kind of looking for what the driving starting geometry was. Is that fair?
Yeah, and I found a lot of stuff. Do you want me to show you that?
Yes, I do.
Okay.
Yeah.
So, okay.
We're looking at your screen, so we're ready to go.
Okay. So, there it is. I believe it was either Assembly 398, 1695. It's one of these. I might have a false start here. I gotta make sure one of them is the right one. This might not be. Actually, it's looking good. Okay. So I exported a step file. This is from the old MMX. This is a template that was made up of just the minimum amount of parts in the MMX, and it's from Martin's development project that I don't think he's really added to in a couple of years. But basically, I tried to find the original geometry that built this thing from the first place. And I have so far been unsuccessful in finding direct sketches that show very specific things. But as a whole, there's still information there. It's just you have to know where to look, and you also have to have a spare 300 hours. So I basically I got access last year, and Chris gave it to me. I think Chris did, or maybe it was Martin. But either way, what you're looking at in front of me is something I downloaded from there, and I brought it into SolidWorks, and then just imported it as a step, is what you see. And then I just started building these sketch on top, just to extract as much info as I can. So first one is literally just the face of that part, it's the face of that part, et cetera, down the line. So I found some things which you might find kind of funny. Some of them are face palms. Some of them are a little bit curious why they ended up that way. And actually, I'm a little bit curious why this is down here. Oh, wait, I know why. Never mind. I'm sorry. I know what that's about. Okay, so pretend I'm starting from scratch. So I did the following. I went and did an offset of this face.
This is the upper frame. That's
the upper frame
component.
Okay.
Right? Yep.
So went in, and then I made a bunch of points. And these points, you'll see if I delete this one, are all the references and then these squares. And I figured some stuff out that will blow your mind. And some of it's good, some of it's not.
I'm ready.
The bad stuff, I'll start a new sketch so that you can see what I'm talking about. I don't want to trash, Martin or Marius or anybody that because they worked hard on this stuff too. But there's some things that I learned that are a little funny about it. So,
well, let's give a blanket disclaimer to that, right? So this is spoken as someone who has ADHD, but has also been the CEO of his own startup, runs a business incubator, right? Is that nobody has to be perfect. Nobody has to be good at everything, right? That's why you have a team. And we should not feel bad about saying Martin did something wrong in CAD, because Martin has never even claimed to be an engineer, right?
Yeah.
So, we don't need to apologize for correcting a mistake Martin has made in CAD. He will point out himself, right? So yes,
okay, great.
Critique away.
Cool beans.
Yeah.
Okay, so in the background here is the other thing. You expect this to be a line that goes from here to here, right? That's what it looks like. It isn't actually. If I do line,
yeah.
If I do a line that is from here to here,
those two in the middle are not actually on that line.
They are not. This one is like 1/4 millimeter away, and this one is a little bit more. So there are plenty of situations that are just like this, where you could tell the design intent was to have that be a straight line. It's pretty clear that that's what it is, but it's just not. Mm-hmm. And because of that, anything that's measured from here and has a mathematical relationship to other things, it doesn't apply. It's just the same way this one does. And so you might get situations where you measure from one thing to another and you find, oh, that looks like it's like exactly 16 millimeters away. But it turns out it's like 16.9985 and then a string of infinity. And you realize the design intent is obviously that it should be 16 millimeters. It just somehow along the way, during the original design, it didn't get mated properly in Fusion. And so this model that you're looking at right now is absolutely full of that kind of issue. Mm-hmm. And this particular frame member,
which is like, that's enough to make any perfectionist apoplectic, right?
Yeah.
There are people who would be like, okay, so it's 0.5 of a millimeter, off. Like,
yeah.
It's still gonna fit, man.
Yeah. So this arc here, I could not figure out why the pivot point of that arc, the the center point, was way the hell over near where my cursor is now. It just didn't seem to be in any particular place. And I don't know why it took me this long. I don't, but I found what it is. And I'll show you what that is right now. This is 80 millimeters. And if I go and make a 3-point arc, start it on this so it ends up being tangent.
Off the bottom of that circle?
This is tangent to an 80 millimeter circle here. And actually this extends all the way to the center of this, but because this doesn't have an X, there's no way to get the center. So it passes directly through the center of the square, the center of this square, and then all these points are coincident to it. So it took me a while to find it, but it's there. And, you know, that's interesting. It means that this was deliberate, which is good. All of this stuff, believe it or not.
So give me some context. Those things that it's going through, that square, that is like the shaft that the marble drops are welded onto? Is that correct?
I think so. Yeah, I think so.
Okay.
So this square is just a stop piece for the registrators.
Okay.
So this is actually dependent upon the registrator, which is what this guy is right here. So I'll turn this back on. So the registrators are here. This is just a stop bar so that when it resets, it hits against it or stops it from going the wrong way, which is fine. This used to hold springs. I don't think it does anymore. I think this is obsolete. If it is, then it is whatever. I haven't.
Yeah,
so
I think the springs go up and down now.
Yeah, so I might not include it. But this thing is actually, and this guy and this guy and this guy, these are all dependent upon this registrator. And the registrator is basically a 17 millimeter by 100 millimeter L-shaped construction line that if I take the terminus, which is going to be, I don't know if it's in this sketch or not. Yeah, it is. It's right there. I think. Where'd it go? There it is. So here, if you can see it in my sketch. So from here, everything over here becomes deliberate placement for. So it's not a problem to place them. Now, the real rabbit hole was when I tried to find this line and where it intersects with this 525 millimeter radius and this square. It looked to me like there's got to be some point that they all converge. And they aren't. It's this is a situation where because this line isn't really perfect where it's supposed to be, this line's relationship to that line isn't a direct number, but it's so close. It's like 15 thousandths of a degree off from 69 millimeters difference between these two. So I decided that these two are just going to be 69 degrees away from each other, and that's just how that's got to be. Because there's I couldn't find any other like deliberate thought process. But anyway, once I do that, all these numbers become absolutely easy to define. And yeah,
and the key is saying that the point of reference that was originally started was the center point of the registrator pivot.
It was right here. Yep.
Interesting.
Everything goes off of this. And I originally thought actually that somehow one of these planet gears played a role in the position of this, but they don't. It's not. The difference, though, is that this line of the registrator is tangent to a circle in the center of the programming wheel with a radius the same size as this. So I can't just draw it as an L shape and have this be directly to the center because it isn't. It's different. I have to make a circle and then make. I'm gonna actually make it 34 at first, and you'll see why in a second. Set as the diameter at 34, but then I'm going to change it to display as radius for a reason, and I'll show you why. So now it says R17, Now, if I make this equal to that, so I'm not going to do it in this sketch because this is really just my archaeological research, what you're seeing. So I'm just going to show you in general. This should be 17. Yeah, it is. Just going to leave it at that, but it gives it a name, and that's all I really need. So I'm going to open this. I'm going to make it equal to that. There, boom. So now, if this were different, this would change. So now this, I can't do it because it's already a what do you call it? It's already in another sketch, so I can't change that. But if I make this tangent to that, then it places this point at the end of this lever exactly in the correct place for everything downstream to go off of it. In fact, is sketch 12 what that is? Let me open sketch 12 because that might have that information. Yeah, it is. I just gave it a different origin. So I just picked the origin as the center. Turn that off. Okay, so this is literally the sketch. So if there's that 17 millimeter radius circle. There's the 80 millimeter radius circle. So I thought originally this was at a 10-degree angle because in one of the earlier sketches from Martin, it is at a 10-degree angle, but it turns out it's really a 94-degree offset from the center. Okay. And if you do that, and if you make this 17 millimeters, and then this line tangent to that 34 millimeter diameter circle in the center, it places this point at a very specific spot that makes all of the rest of them be offsets. So the center of this center rectangle is 260.5. The center of this 260 rectangle is 455. And then, I mean, clearly it just falls all into place.
Yeah.
So there are some strange design ideas that I don't think I would have done. Like, for example, this 730 millimeter offset is to the corner of the square. I don't really see why that would be. I would have picked either the center or maybe an X offset.
Yeah, you just mentioned a bunch of stuff and looked for where it came to round numbers, basically.
Sort of.
Yeah.
Kind of.
You do have a lot of time on your hands.
Yeah. But anyway, all of this, what you see right now, fully defines all of the super important connections as they existed when he originally designed this machine 4 years ago or 5 years ago at this point. I'm not even sure when it was. But from this information, you can then build on the rest of it. And if you can remember last summer, one of my arguments against starting the community aspect of the original remodeling, which is fully underway and doing fine in Fusion, was because I just didn't have this info yet. There was still a lot more research I had to do, and the problem is you can't undo everything once you find this information. So the Fusion model today kind of doesn't have this info in it. It's just based on
it's all derived from some previous version of something. So the big question is, though, you found this, and you can redefine the thing using kind of round numbers that make sense, right? So if we were to recreate the skeleton for the MMX-T, you could do that with what you just found.
Yeah, and so I did that actually in another SolidWorks.
Though that's the question.
Say again?
But is it the best way to do it? Like, if we were to do it over again, right now that you did that, given that we're not modifying an existing machine, right? We don't have to make parts that fit that existing machine. If we were to do this as we make this new skeleton, should we be changing it? Like, make those first two points part of that straight line? Should we pick a different reference datum and just make things even numbers based on the centerpiece of the programming wheel or something like that?
Mm-hmm. So my personal opinion is that I don't even think we should touch the frame at all in the initial part of the design. I think the frame should be it should be a method to hold the parts that you already designed so that they're in place and logically sorted. Because if you design the frame first, you're constraining yourself unnecessarily to specific designs and geometric offsets and things. So, and it's another reason why the frame should share the origin with, the machine itself, right? Because it's the static thing that you sort of allow everything else to hold in place once it's finished. So so the frame for me should not be an input. The only reason I'm doing this first is as a design exercise. Right. I don't expect to use any of this data whatsoever in the touring version because, again, there's the original Marble Machine X that's being made right now it's not up to the task, right?
Right.
We shouldn't look at this as information that should survive.
Right.
I actually think that we should start with the mechanical function above all else.
And not design a frame first.
No, I don't think the frame should come first at all. On the other hand, knowing...
I mean, that makes sense, but it's just not the way I was thinking about this. Right?
Okay.
I mean... And that's a good thing. You've successfully bombed a preconceived notion that I had, and it does make sense, right? Just design. I mean, I guess you have to understand that all the components are going to be held, right? But it's kind of like the notion of paving cow paths, right? Which is the depending on if you're like someone who is trying to create an organization, like the term paving cow paths is a bad thing because you're just saying like we're going to like institutionalize people's bad habits.
Right.
But there are people who say that, and like if you're a city designer, right? I mean, like the whole thing about paving cow paths came from Boston, right? The street layout of Boston, which is horrible, came from the fact that these are the paths that people brought cattle to market, right? And those turned into streets, and like the layout is horrible and it's a mess. But there's also instances where, like if what the people are doing is the most efficient thing, like there's people who've built like apartment complexes and then not put in paths and just put in grass and then see where the paths get worn and then they pave those, right? Anyway, that's ADD tangent.
It's a very good point.
Yeah.
But like, you could include the frame first as long as you make it dependent upon the rest of the parts, I guess is what I'm trying to get at too. So like, that's one of the reasons to do the layout at the top of an assembly, because if you lay out everything at the top of the assembly, like where this gear goes, where that gear goes in space, then the frame is just an output of that, right? It's just something holding it all together. Right. It could still sort of be the first component technically in the assembly if that's where you want it in your tree.
Yeah.
I don't think anyone's arguing against that. I'm just saying that if designing the frame first is presupposing a lot of things that it forces you to work within constraints that didn't exist except for in your own mind.
Right. But what we could do, though, is we could provide a reference sketch that isn't necessarily the frame, but it is reference geometry. Like we have this shaft here, and if you want to change it, we can change the coordinates of that shaft. Right? We can provide basically, describe where the individual parts are, but not necessarily how they're connected. Right?
Yeah. So this is a design that I blew up. And it's really too bad because I was quite proud of it until it exploded. And I have the mind to actually abandon it now, which is kind of annoying. But basically, like, this is not how I designed it. I changed a couple things and it just sort of went upside down.
Yeah. Happens to the best of us.
Yeah, but oh, come on! Oh, it's rolled back. Okay. But so this is the 3D sketch of the frame, right? That's all it is, actually. There's nothing else in it but that frame. Mm-hmm. Technically, this is at the top of the design. I'm actually kind of curious how, when you created a design, these sketches ended up on top before the first part, because usually they happen at the bottom. But either way, this is my initial first sketch. And if you look at it, there's actually, you might think, wait a minute, all I see is some belts. And that's because it's all blocks. Everything in it is a block. If you look at all of this, there's a programming wheel block, and there's a planet gear block, and the
if you aren't using the layout thing, can you use the block tool?
What do you mean?
Well, if you do layout, if you do an actual layout, you can't use like the path length tool. You can't use there's a variety of things. Like I don't even think you can do slots in the
the layout sketch at the top of the assembly. It's really limited, actually, what you can do in there. And one of the things that are limited are these mega blocks, which is what I'm calling them. I don't know, maybe they have another name. But mega this is a block that includes 3 blocks. And they all stay together. So if I move block 1, they all move. And in fact, speaking of moving, did I think... Oh, yeah. I have traction enabled. I don't know if you can... what kind of resolution you can see. But if you look at the construction lines, you can see them move.
Oh, crap. Look at that. You can do that in a sketch?
In a sketch, yeah. And it's because of blocks. And actually, it's called a traction constraint, and that's actually what you see here, what I just highlighted.
Yeah, it's like a gear constraint, but it doesn't
looks like I turned off. Oh, there it goes. Now they all move. Every single one of these things is connected with traction. And it does a few things. First, it validates your design so that everything that you have in front of you is connected and actually functions, and it does. And if you look at it, every single thing in this thing is connected. So that was successful. The problem is I couldn't get the damn thing to be fully constrained, no matter what I did. And I actually even locked one of the what is it over here? I locked the angle of the first moving thing. It should lock everything because the belts are engaged, the gears are engaged, and so that means nothing should move if I lock anything.
Right.
When I do that, and then I save the sketch, it, does not become constrained. Yeah, see, it's not all, it's still this
is the thing you were telling me about. You had a post on the help forum for.
Yeah, it just will not do it. Yeah. And I've tried everything. In fact,
maybe you should just not do that.
So I mean, that is an option. To be honest, having all those traction constraints,
or not pin one of them.
Yeah, it makes it a little complicated. But on the other hand, it also proves your validation. And the truth is, there isn't that much information in here. You're just talking about a pretty simple gear and belt layout.
Right. It is cool.
I had it fully working. Up to a certain point, I actually have rebuilt this about 5 times in other designs, and I got it to be fully constrained until I started adding these planet gears, and then that's when everything blew up. And so I actually did a few things to try to see what I could do to fix it. And one thing I did was make a formula that determined the belt length and just ignored the belt. Right, so the belt actually is what determines what angle this whole assembly is around this wheel, right? Because if you think about it, it's going to rotate around this circle right here, and the belt, when you fix its length, puts it in this exact XY coordinate, and that caused a problem because this offset here, the 265 and the 20 millimeters, if I do that and also the horizontal, they would all go over constrained. And it doesn't make any sense because, this is my anchor point. Everything is based off of that solely. And I could not find any places where I was trying to double up, right? It just made no sense. So I tried deleting. I deleted it back down literally to nothing and then started over again. And then I even went as far as using a formula to do this offset so I could get rid of this. because it's a construction line. I felt like I could get rid of construction lines. The only reason that's there is to make this 10 degrees off, and it has to be based on the original MMX. But if I just, use trigonometry, I could get this as an X offset from that. And I did that, and it still didn't do it because I wanted to avoid, see all these 4 coincident constraints?
Yep.
A lot of these circles have coincident constraints to other things. And actually, I thought maybe that's my problem. Maybe if I just stop doing coincident constraints and do everything I possibly can with concentric constraints. That way, the center of the circle is just they are coincident, but by extension of them being concentric.
Yep.
And by getting rid of these construction lines, now I've made it so that they, there's no extra geometry that this thing tries to get confused by. So my next step was actually to do a very similar offset with this guy based on the length of the center. But I haven't gotten that far yet because it's a really complicated mathematical formula if I could, it's super shitty. And so I didn't do that yet. So I'm planning on doing that. But basically, the whole point is I want to have as little construction geometry as possible at the top level so that there's nothing that I can accidentally make coincident to by accident and then end up, if I change, I lose.
Right.
So anyway, that's the point. And so there's a lot more I have to do to figure that stuff out. But basically, This is me not designing the frame at all. It's totally... actually, it would just get in the way.
Right.
So I think that once all this gear train is done, I think that if that looks like a viable construction, like based on its size and everything else, then you can design a frame that fixes all that in position.
Right. So maybe what we should be doing is deciding what are our critical control points, right?
Right.
In that sketch. Where do we want to reference things from? And just put that together.
Yeah, I agree.
Let's do that.
Okay.
Let's do that. So here I'm going to do this. So I have, if you look up at the top, this is the assembly, the MMXT assembly. Nothing in it. I just have one sketch on the front plane. I've drawn a few circles, but let me even get rid of those. All right, so we're going to start me off. We have the origin point we were going to put in the mid. We're going to put at the top of the base frame, right?
You're talking about the MMX?
Yeah.
Okay, so yes, I think the origin point, the best possible place is the top center of the frame.
Okay, so that origin is there. And so then so the center of the programming wheel, or where do we start? What's the first reference point we put in there, and how do we tie that to the origin?
I say your first reference point should be your human interface to the machine, which is probably going to be, it's that 265 millimeter in the X and 20 millimeter in the Y, or actually negative 20 in the Y. That's your first.
You said 265?
265.
I don't know. That's this weird coincidence that I put it and it actually came up. That's the default value, 265.
Great.
That's very
so
weird.
If I were you, though, I would
take
this I would take this opportunity when you create that to make it into a global variable, though, when you're creating stuff like this.
Yes, but that's not the subject of this video.
No, but it's super easy to do. If you just press equals.
Yes, I know. So let me get this dimension in, so you're not challenging. Is it negative 20 millimeters?
Negative 20. Well, just 20 because you're already offset from it lower.
Okay. So, all right. So let's make the global variable. So that is called what? Equals quotation mark.
I would say you don't want to do the quotations, I don't think, because if you do, you're going to... or maybe you do. Sorry.
I think you do.
Mind. Yes.
Crank what?
So first step is probably not to confuse a global variable with a global variable comment. Right? So,
yeah.
So I would say like CR_YOS, something like that. like crank Y offset. Some way to make it short.
CS
whatever.
Y O.
OS. Yeah, or O. That works. And then enter, and then it'll ask if you really want to create it. You press yes. There you go. Boom.
Okay.
So now that's global variable, and you could do it while you're doing it.
Yeah. Okay. So equals CSXO. Parentheses. All right. All right. So we're there. We're good. And let's check. We have equations. We have our equations up there. Beautiful. All right. So that's the crankshaft offset center point. What else? So what's next?
So
Brandon is agreeing that if we don't do the parameters now, that we're going to have a harder time later. So
yeah,
okay.
I think that maybe it's, in hindsight, I should have told you while you were doing it. I would have made that a circle because you know that that's going to be a gear anyway, not a point.
Yeah, but there's going to be a pitch diameter, right? We still want to do. Oh no. Well,
you don't have to. Yeah, you don't have to name it now, or I'm sorry, you don't have to tell it what diameter is now.
Right.
But see now you've made it coincident. So now you have two sketch entities. I guess what I was trying to say is that point should have been a circle. So do me a favor.
Oh gosh.
All right. No. Don't do anything yet.
What?
Don't delete it. Draw a circle anywhere on the screen. Doesn't matter where. Just a circle somewhere. Okay. Now right click on the point. Nope, not that. On the point. Not that.
This?
Not the circle. The point that you sketched.
Oh. Yes.
Right click on that.
Mm-hmm.
You got to unselect the circle.
Oh.
Okay. Right click. Now click replace with, which is one of those. It's the one right above your mouse, actually. Oop. Over. There you go. Replace entity. Now select the circle.
Replace this entity with this one.
Okay, now you can select the point. Oh.
No, what did I do?
You didn't have the point selected. Is it not letting you?
It's not letting me.
Interesting. Okay, didn't realize. I was trying to save that constraint, right? Or your sketch or your dimensions. I was trying to make it so you didn't have to delete them.
Well,
okay.
Thank you for trying to save me.
Do that.
But now that we have this guy equals.
Select it there. Yeah, there you go. Boom.
All right. It's equal to 6YO. There we go. All right, so we're back, and there's no all of that, so we can get Brandon saying SolidWorks is a land of doing the same thing 3 times to get the result you want. I agree, especially if you're catting with David Lewis. I don't know that I would have minded that much. What's the downside of having that coincident relation there? You just have extra geometry.
Yeah, you want your sketches to be absolutely as uncluttered and minimum as possible to accomplish the mission that you have. So if you have 1,000 things that overlap with each other, and when you have to go in and do your extrude, you have to pick. It's a mess.
You're picking which relation and trying to figure out what it actually relates to, and yeah. Although in SolidWorks, it tells you what it relates to. It does not do that in Fusion. All right, so what's our next piece of reference geometry?
Okay, so what do we want to create next?
Well, that's what I'm asking you, right? In terms of the logical flow, right? We have the center of the frame, we have the input shaft, right?
Are we recreating the Marble Machine X, or at least figuratively?
Yes. We are. Okay. We are assuming that there isn't going to be. We're assuming that there's not going to be extreme form factor changes. Right?
Got it. Okay, got it. So you want to have a tangent circle that's got a horizontal constraint to that circle.
Okay.
That's actually much, much larger than that one.
But horizontal to it.
Yes.
That one.
Yes.
Okay.
Okay. Now, the next step depends on if you already know if you want to dimension them in terms of how big they are.
Mm-hmm.
It's 100% going to be based on module this time and not on some like printout, right?
But we don't even need to design the gear. We only need the ratio, right?
Yeah.
So if these are pitch diameters, right?
Exactly. So all you need is the module and the tooth count to get that pitch diameter. That's all you need.
Yeah.
And so the module is going to probably be 6.5 or possibly 7. That's not totally sure. I have that information for the original one. They're wacky numbers, but they have to be because they're based on imperial gears.
Right. So we're going to call it gear ratio, right? This is what we did in the last time we were doing this. I have to capitalize gear ratio.
Mm-hmm.
I think we did it as 6, right?
I'm pretty sure it's 112 to 14. So whatever that is, I think it's that. Anyway, I could be wrong.
It's not 6 millimeters. It's just 6.
It's 8 to 1.
8. Oh, that makes sense because it's a music time thing, right?
Yeah.
How do I make it so that there's no unit? I don't want to give it a unit.
Well, it doesn't have one by default. In SolidWorks, you have to add a unit.
Okay, good. All right, so going back to this sketch, we're going to say that what are we going to... We have to pick one of the 2 diameters, right? To give it a starting diameter.
My thought is that you could do all of that in the global variables.
Right.
You can do that in the sketch if you want, but I mean, honestly, you need you can't just use an X value, in your dimension.
Yeah, I'm with you, but I mean, so if we're doing this, saying that this pitch diameter is some fraction of that one, right? We've already set up the ratio as a variable. We have to.
I get it.
So what's the first diameter?
So
is it
exactly
the programming wheel diameter?
So you can pick whichever one you want, but it's 14 and 128, which is 8 to 1. Sorry, not 128, 112, which is 8 to 1.
Right.
So you want, so you already picked 8. The next 2 inputs are module and number of teeth.
Do we need to do it that way?
Say again?
Okay, sorry. I'll do it. I'll do it the way you're telling me to, even though I don't understand where you're going with it. Because I'm going to learn something.
Got it. You can change the module later on if you want. This gives you an opportunity to do that.
So what's the module? 2.
Just for now, pick 6.5.
6.5. Okay.
I'm not sure that's exactly what it was, but now you got to talk about what you have to give one of them number of teeth. Either of them has to have one of those 2.
Main gear teeth.
Got it. Although that's the marble lifting gear, just FYI.
Yeah, that's fine.
Okay.
On
the marble machine now, that's 112. Okay. So just as long as it's divisible by 8, that's all that really matters.
Okay. Well, then, should we make this a multiple of 8? Is equal to,
Well, so if you want to know how I would do it, I would say that you could say main gear teeth equals 112, right? Mm-hmm. And then you could say pinion equals main gear teeth divided by gear ratio.
Right, but we don't. That doesn't need to be a variable. That could just be in the sketch.
Sure, but you might need that number later too.
But so how do I get a diameter? Like, how do I actually constrain the sketch behind this using this?
Yeah, the diameter is your module times your number of teeth. And so both of those need numbers, or one of them at least, in the sketch.
Okay. So see that's what I didn't understand, like why you were doing it that way. So that is equal to global variables module times main gear teeth.
Right.
Okay, then that's good.
So, yeah,
and then
this one is going to be with the other one divided by 8. But again, you can actually enter all these formulas in global variables and then have that available as a dimension that you don't have to put an equation in this. Now, there's a number of reasons why you'd want to do that. One of which is that if it's in the global variable, then like when you need to refer to it again, it's there instead of in the sketch somewhere and hard defined, right?
Right.
So there you go. So now all it needs is that horizontal constraint, and then it'll be fully constrained.
Does it? So this one is horizontally constrained from there?
Yeah, they are both. Well, they both are in the center of the top.
Oh, that's where the two cutouts are. Got it. Yeah. Boom.
Fully constrained or fully defined.
And we've got good parametric awesomeness. Okay. Cool. So we've got that, and this is MRL. This the marble ring lift 1? No, it's not.
It
is.
It is. Uh-huh.
Okay. I'm actually going to because just so that it's not main gear, because that's not right.
Yeah, there really isn't a main gear, actually. I think it would be a mistake to call any of them a main gear.
But marble ring lift 1, anyone who's as deep into this project as you and I are going to know exactly what that is.
Uh-huh.
So, okay. I like it. Edit that sketch. So we're fully constrained. What's the next key geometry we're going for?
So the compound gear is concentric with the marble lift gear, and that's 16 teeth, but it's a different module.
So that's this guy, right?
Yeah.
Oh, no.
Yes, it is.
Oh, it is. Okay.
Yeah. So this gear shares a module with the programming wheel, the big gear around the programming wheel.
Yep.
So I'll have to look at mine. I haven't actually done that in a while. I have to change screens here. Look at my equations here. So that module is 7.03063.
Do we want to change it now? Please?
Well, I say make it 7.
Yeah. All right. So now I actually have to edit the description because that is not just one module in the machine, right? Should the whole machine have the same module?
In a perfect world, yes, but in the land of the Marble Machine X, there are 3 different modules.
Oh God.
So
do we want to make an executive decision to change that?
I honestly think that it's probably a good idea to change that. But on the other side, it actually doesn't matter because once you enter that as an input, right, it no longer becomes any of your concern because all you care about is the fact that it has a there are basically 2 different schools of thought with that. It's either all uniform, all the same, or not.
Right.
And if you were buying stuff, from a supplier, of course you want to spec what you can actually buy, right?
Right.
So if you have some module with like an infinite decimal point, you can't buy that. Like you can design it all you want custom, but you can't buy it. So what's the point of designing with it?
Right.
The whole point of module is you look in a gear catalog and it'll list, how many modules, what's your module and how many teeth, and that's literally the only spec you need to be able to do this.
Right. Okay, so I changed the first module variable to be the MRL module, and then I have a new module for prog wheel module.
There you go.
Which will make 7.
Yeah, 7.03 something or other. So 7 sounds good.
7. Okay, done. All right, so then prog wheel teeth.
128.
One, 2, 8.
You use double quotes.
Oh. Formatting matters.
All
right. So then going back into this sketch. So this guy is equal to prog wheel module times prog wheel teeth. Done. And then this gear ratio is the same, right? It's 8:1.
I believe so. Let me. I know it's 16. So whatever 16 figures into that. I haven't really done the math. 128 divided by 16 is 8. So yeah, same ratio.
Okay. Good. Now we have those two sizes. And how do we? We're not constrained here this way.
Nope.
So how do we place that? Or does that drive off something else?
No, you have two choices to position the axis of that wheel there. The first choice is to use a belt feature so that you don't have to do any crazy math.
Mm-hmm.
The second choice is to come up with a very complicated formula that takes into consideration the pitch diameters of the belt pulleys and also the length of the belt, which I've done. Don't get me wrong; it's something I've done.
Why can't it be 100? That's a good number.
Yeah, because, and don't get me wrong, that's another way of doing it. You can certainly do it that way, as long as you can position the belt properly. By having a belt that fits within the envelope, and if you include a tensioner, then to have the tensioner actually in a logical place.
Right. Well, the belt's going to be the same no matter where we put this. It's not going to change. I mean, the length of the belt is going to be the same.
The length of the belt is determined 100% by the position of that point right there that you just moved.
But it's running to. Oh, is it running to this thing?
Yeah.
Oh, okay. Never mind. You were correct.
Uh-huh.
So then we want to do. We don't want to. Okay.
Yeah, you can do exactly that if you want to see the formula that I had to do to get that. You're welcome to do.
No, I don't want to.
The number, just so you know, is 749 point some decimal.
Okay.
But it's I believe it's like 12 something or other, 749.12. But that's based on the module of these gears being these weird numbers, not these nice numbers that you have.
Right. So should we do I don't know. Talk to me. How do we do this? What's the best way? It seems to me that the offset of this shouldn't be driven by what kind of belt is available. Because
it's exactly how you have to do it. I mean, look at my sketch.
But if you have if you have a tensioner in there, right, it's going to change your belt length, right? So we can get it close. And he actually added tensioners onto this one, right? Because that belt is the one that it goes under the base, right?
Yeah. So originally the belt could barely fit,
right?
And now it's stretched out to the point where it barely hangs on.
Yeah. So let's give him a tensioner, and then let's not have that be the constraining geometry.
Well, I agree, but you still need to know what belt will fit.
That's true. I'm just saying let's not have the belt drive the. That's the thing. Theoretically, I don't like the idea of saying part number 57281 from Gates belt drives is going to, make a major, layout design decision, right? I'd rather do something goofy, be like, hey, let's base this on the golden spiral, I'd rather, have those relationships driven by something other than that. And if we add a tensioner, then, which there is on the machine, right? Then we can do that.
I mean, you can. Don't get me wrong.
Yeah.
Just realize that in the end, it doesn't sound like you're constraining it to the belt, but you kind of are, because you still have to be able to fit a standard belt, because it would make also no sense to buy
or to design a machine.
Belt.
Yeah, to design a machine that required a custom. I totally agree.
So even with the tensioner, the tensioner has to be in a certain spot for the tensioner to function.
Right.
So it's like you're never really off the hook designing around a belt. It's not something you can just avoid. You can make it so that the machine fits a belt you want, or you can make the belt be something that conforms to where you want to put the thing. But the thing is, you have to know that before you just say, okay, this is where it's going to go forever. And that's just a thing.
Right.
On the other hand, it's not hard to fit a belt on here with SolidWorks. So, I can show you that too.
Right. Well, I was just thinking, like, we could do something. Well, let's draw the belt, right? Let's do that kind of. I'm going to place points here, and I can do. Whoops. I make that construction geometry, and that.
I tend to do all of these sketches with everything in construction.
Yeah.
It's less distracting. But just FYI, you can also turn off that shading.
Oh yeah.
It's that box that's gray at the top of your screen right now. On the right side.
Oh, okay. Cool.
So
good to know.
If you turn that off, the sketch contours don't get shaded.
Okay. All right, so let's draw a belt.
Oh, no. There's a function for belts. Like, you want to draw it if you want to, but there's a sketch entity for belts.
Okay, where do I do that?
Okay, first step is you have to convert the things, or you have to actually create a block because they require blocks. That's half the reason you need to do it.
So I need to sketch the belt first.
No.
Okay.
No. So you can either convert a sketch entity to a block or just create a block and then put a sketch entity into it. Okay, but you don't have the sketch entity that you need to insert it, so you have to actually create the entity first. And all you have to do is create a circle and you're done. Don't even measure it. Now that's a center point arc.
I know. Okay. I'm being obstinate, David.
Okay. There you go. Make block. There you go. Now click. Yep. Now go and don't touch anything else over there.
Mm-hmm.
You'll see there's a take that and put it on the circle, the center of the circle, not that circle, the block. I don't know what you're doing. Take that. Yeah, there you go. Mm-hmm. Put it out in the center of the circle.
Oh.
Boom.
Okay.
Now get out of your block. Okay. Now take the other one. Or sorry, what am I talking about? Draw another circle.
Okay.
Okay. Also make it a block. Make sure the insertion point's in the middle. You don't have to do the layout sketch block. I actually don't know what that does technically, and I haven't really found a way to figure that out yet. So, okay, so now you have two blocks. Now you can create a belt. So you go under Tools, which is at the top, Sketch Entities, Sketch Entities. Now all the way at the bottom is going to be belt.
Look at that.
Now select both blocks. Now you can tell it which belt you want to use or not. It's up to you. But if you have driving, then that means that the belt is something you've decided how long it is. Mm-hmm. So that's where you would put that. If you don't do that, then wherever the circles are, that's how long the belt is.
Got it. Okay. Could I put the tensioner in here too?
You could do that if you add another block, yeah.
Okay. Let's do that. Mm-hmm. Interesting. New discoveries in SolidWorks. All right. So, tools, sketch entities, belt chain. All right, driving. How do I know?
So there might be an issue. I don't know this as a fact because I've never tried to make a belt with unconstrained pulleys. Mm-hmm. But you haven't actually determined how big they are.
Right.
They're overlapped. Why are they overlapped?
They're not. Yeah, that's weird. Well, they're also.
I
don't know. Let's just give them.
Yeah, just give them random numbers. It doesn't really matter right now. No, you have to finish.
That's
The only way to do that is actually go under Edit Sketch, because if you delete that little menu item, yeah, okay.
Oh, we're going to do this guy. It's a 50 millimeters. Okay, so that should let me do it?
I don't know. Your guess is as good as mine. I actually don't know why it didn't do it before. Creating a belt. This is weird. What happens if you delete block 2? Try deleting them all and just add them again, because I don't. Well, you definitely. Oh, I see what the problem is. You selected them in the wrong order, so you have to select the ones at the very extremes and then the idler in the middle. What the fuck?
We're back in the really exciting YouTube content. Think of what the hell is SolidWorks doing?
So it's never done that to me. I honestly don't know why it's not creating.
You don't have to actually draw the path?
I wonder if you have to define one of the pulleys positions. Like it won't let you do a belt in space.
Can I do that?
I'm just grasping at straws. Yeah, I mean, I'm sure that'll work. Not sure why you're selecting them in advance, but...
What, force of habit? Selected pulleys are overlapped. No, they're not.
What if you flip the belt side? Shouldn't matter, but...
It doesn't look like it's doing anything.
Huh.
All right, let's go on. Let's figure that out some other time.
So I'm totally confused because obviously I could do that. I don't know what's preventing you from it.
Right.
So.
I mean, it could be something as mundane as I need to restart SolidWorks.
It could be.
Yeah. So we're going to kill those. So let's move on. So allowing this guy to float here, right? How are we going to define the center point of this thing? Or what's the next geometry that we want to make that might then further drive where that center point is?
So I think you have two choices, right? You can select either an offset from the Y or from the X. And I honestly think that the more important one, if it comes down to that, is you don't want the programming wheel to strike or overlap the frame. Right. If you think about it, the Y direction, it's pretty close to the frame. Right. So I would define that in a point where it clears the frame, and then you'll fully constrain it.
So we're going to put a point at the bottom of this guy and have it clear.
I don't understand why you'd have to do that. Why would you have to do that?
Oh, I don't know. Because otherwise Can you dimension that without the point?
Yeah.
No. Okay.
Sorry, I hate to say it that way, but yeah, just you can actually just pick the origin itself and the circle, and then yeah, there you go, just like that.
Well, I was just trying to do something like, if we did the point here, right, and you would know if this is the top of the frame, you know that I have this is my clearance. I have 20 millimeters of clearance.
Okay, well, I've got a better way to do that exact thing. I agree that that's a legitimate, actually, way to do it too, but you don't need the point either.
Oh.
So if you select the circle and after you've held down Shift, it does the same thing.
Oh, okay. And since we're being perfectionists here, Shift. Look at you. All sorts of fun facts from David Lewis today. Okay. So we got our 20 millimeters of clearance above the frame.
Yeah, I like that.
Does it look like it looks like if you try to change this up, much more, it's not going to go, right?
Yeah.
30 is the most.
I like that being the standard that you measure it by. I think that's a really great idea.
Although this is the pitch diameter. It's not. There's the teeth are going to go past this.
Yes, that's super important. So consider that clearance might end up being a pretty complicated formula.
Yeah.
But still, once you put it into the formula, you never have to look at it again. It just becomes a thing. So where are we now? So consider, though, that your job is not done. At some point, you're going to have to figure out the belt issue and make sure that position can support a belt that you can buy commercially that an idler will fit somewhere in a rational spot. Right.
Yeah.
Because you might find that like a belt in that exact range, there's one 100 millimeters shorter and 200 millimeters longer, and now your pulleys are in like no man's land. So you just got to make sure that you don't accidentally design.
Yeah. So there's a sanity check on that constraint.
Right.
Yeah. Okay. So what's our next major geometry that we're going to define from this?
Okay. From this, I would say your sun and planet gears probably.
Okay. Should I do a polygon?
You shouldn't need to, and I'll show you why. I would say you don't need to sketch the 3 planets though, because those are going to be patterned.
Okay. Oh, okay.
You just need one of them. You just need one.
Yeah. Oh. I know. Okay. Yes, that makes sense.
Yeah. So same deal. Your sun and your planet gears. By the way, that the gear in the middle of the programming wheel is not the sun gear. That's the pulley for the belt. So just keep that in mind.
Right. Yeah. Okay.
So you're going to want to build your sun too. That's what I'm trying to get at.
That's right, because this line is the external.
Yeah. So that's your ring. That's your ring gear. You still need your sun.
Oh, yes. The sun.
Yeah. And so just remember, you just made a whole bunch of things coincident with each other in the middle. So just keep in mind it's going to get dicey in there. There's a lot of things coincident to each other.
Is there any avoiding that?
Sort of. But, you've already created them. Don't worry about it now. I like concentric constraints for circles that are concentric with each other.
Right.
Making them coincident to each other in the center can get pretty dicey. So you want to dimension obviously your sun gear and your planet gears, but you're going to do it the same way that you did it with the other ones, which is by telling what the module is and the number of teeth.
Yep.
So you only need to do one of the planet gears because they're patterned.
All right. So what's yep, got it. So manage equations.
Okay. So now the original Marble Machine X, the planet module is 7.58733. So use your judgment, whatever you want it to be.
What was the number again?
7.58733.
7.5. 7.
Sounds good.
We can change it, right?
Mm-hmm.
And then planet teeth.
It is. Oh, shoot. look. Planet gear T. So the sun gear is 16. The planet's 32. But I have the planet gears as a ratio, just like you did before.
Right.
So,
but is the ratio still 8?
It's 2-1.
Oh, okay. So planet T. Planet gear.
Is anybody even still watching?
Since you're one of the 5 people watching, yes, 4 poor souls are still watching.
Nice.
Yeah.
I hope they're getting their money's worth.
I hope they're like cooking dinner or boinking their partner or doing something more interesting than this at the same time.
Okay. So the ratio is 2-1 or 2 whatever.
Mm-hmm.
And you got your teeth, you got your module, you got your ratio. You're good to go. Everything's there.
Okay. So.
Okay.
So this is equal to planet module times planet teeth. And then this guy.
Of whatever the other one was. You could give it its own formula too, but it's that divided by 2.
Mm-hmm. That divided by planet gear ratio.
Yep.
Boom.
Okay.
It's still constrained because it doesn't know where it is radially.
Yeah, so it's 10 degrees off of vertical, biased toward the front of the machine. If you like trig, actually, there's a very clean way of doing it without a construction line, but
I don't.
But that's up to you.
Actually, I did really well in trig. Am I going to have to give it a construction line to angle things off of?
No, I never do that. That is a cardinal sin.
Oh,
I do it from the front. I do it from the right plane.
Oh, got it. Yeah, that makes sense.
In Fusion, you unfortunately can't do this, which is annoying, but here you can.
Like that.
Boom. Yep.
Okay.
Now, your pulley isn't constrained to size, but that's the only thing there that isn't.
Yeah. Does that look right in terms of the pitch diameters? I guess it does.
It sure does. Yeah.
Huh. Okay. So let's leave it there because it's 3:00. We have the first part of the touring version of Marvel Machine X cleaned up, driven from how you actually make gears. I feel good about this, David.
Well, it's a good starting point anyway.
Yeah. So next week, so the next things that we're going to do are going to be putting in places like where the registrator pivots are, where the actual finger pivots are, like the manual trigger pivots are, right? All those other things.
Yeah, why not?
And we won't design the frame. We'll put in the points for the components, but not design the frame.
I honestly think that it's if nothing else, it's not useful at this point to have that information.
It's one of those things where it's not the way I thought of it, but it's actually a liberating concept.
Right.
Love it. Cool.
I mean, don't get me wrong. I've designed the frame 100 times and have spent hundreds of hours on it.
I know.
But I would love to never see it again.
Right.
So
yeah. Well, you're volunteering for a weird position if that's your goal. Cool. All right. Well, let's close this guy out. Oh, we should probably save this with bookmarks. Let's see if we can do a good job. Save with options. Extracting file information. There's not a lot of information there to extract SolidWorks. Come on.
Yeah, that is kind of a lot of time.
Yeah, and the bookmarks, it's coming up a little faster. So, bookmark editor, music box project leader. Oh gosh, see this?
Yeah,
I need to cancel that. You have to. That's like the cardinal sin that I had this in this wrong workspace. I almost saved it in the wrong place, and I'm not exactly sure if you save it in the wrong place that you can fix that.
Well, I just saw an option I don't remember seeing before.
What?
Save as new. That's kind of interesting.
Oh, I didn't see that. All right, so this is chassis.
I guess I would almost call it layout, but chassis works too.
Well,
I mean,
so
yeah,
I actually already have the hierarchy wrong here, because if you see, there's also music box is in this same level, so there needs to be an MMXT bookmark.
Yeah.
Right. So I'm actually going to cancel this. Let's do it. Let's do it right. So go into the platform, go to my bookmarks editor, which I'm going to drag into my favorites because it probably needs to be there. And yeah. So new bookmarks. And this is going to be MMX. We can. And then can we drag these into those? No, we cannot. But
really, that's unfortunate.
Well, it's okay because there's nothing in them, so we can delete them and whatever, right? But within this one, we can make a new bookmark. And this will be layout. That good? That descriptive enough? I mean,
Sure.
you can have multiple things, right? You could have chassis.
But what are you bookmarking? Are you bookmarking the assembly sketch itself? Are you bookmarking like the whole thing?
Oh no, you're right. It is the whole assembly. Yeah. So I'm actually not going to use either of these bookmarks. I'm only going to give it the root level. All right, let's see if those propagated here. So now I'm going to save with options, give it a bookmark. I'm not going to use the sub bookmarks. It should be the only thing that only has there you go. Save.
Huh.
So my homework is redo the whole music box, because we're going to talk about that again next week, and then clean up all the freaking bookmarks, because we started that however many months ago, and we did it in a very random sort of way. So I need to clean up all of that stuff so that it makes more sense. Right. So cool. All right, we'll cut it off there. Thanks to both of you who are watching. Thank you, David, for hanging out with me on a Friday. And hopefully we'll do these in person sometime soon. You come up here and show me how to use my my mill and my lathe.
Oh, that reminds me.
Yes.
I got my second vaccine shot yesterday.
Nice.
So Pfizer, and I don't feel so great right now. In fact, you might have seen me earlier taking a couple of pills. I took some Aleve.
I thought you were just a junkie.
Yeah. But I had my second vaccine dose, so I am vaccinated.
Nice. I'm getting my second in a couple weeks.
Nice.
Yeah.
Cool.
All right. Stop the stream. Thank you, everyone, for watching. We will be plugging along at this project for the next foreseeable future. And look, we just have validation that someone still is watching. So, thank you.
Oh. Oh yeah, somebody's a big fan of Brady Heron, I guess. Kofi Einsuchtigi. I don't know. I think it's German, but I don't know what Tigi is. But
got it.
Anyway,
all right.
Yeah.
Ciao for now. See you guys.